program needs to make an input or output operation, for example, reading or writing to a file, waiting for user input, or fetching data from a server, such operations require our program to wait for the other side to respond. In a purely synchronous programming language, these operations would be called blocking, meaning the program will not continue execution until it has received a response. This is generally not a desirable result, as we'd prefer our program not to come to a halt when waiting for a resource, but use this time to do other things instead of being idle. Promises are JavaScript's way of handling asynchronous instructions, as opposed to synchronous ones. A promise is a JavaScript object like any other. Its role is to stand in place, or in other words, be a proxy for the actual object or primitive value that is to be returned once the waiting is done, or if for some reason the wanted response cannot be received, to catch any errors. Promises therefore allow us to write code that uses an object or value that we do not yet have, or if we don't receive it, to handle such cases. To create an object of type promise, start by instantiating it using the new keyword, followed by its constructor. The constructor needs to be passed what is called a callback function, which will be executed as soon as the object is created. The callback function itself has a required parameter of type function, which in this case is called resolve. We pass the value we want our successful promise to return as an argument of the resolve function. We will store this promise inside a variable called promise. To access the value from our promise, we use the then function. If or when the promise is resolved, then the then method is called. Finally, if we want to do something with the response, pass in a callback function with a single parameter called response, which will stand in for a response. You can do anything with this response, but in this example, I only capitalize it, then log it. Because the then method returns a promise itself, you can also chain them like so. Make sure that the previous callback function returns something, or else the argument of the next callback function will be undefined. This is good, but in a real use case, a promise won't always resolve. For example, a user might leave the prompt before pressing enter, or our internet connection might time out when we try to get data from a server. In cases like these, a promise might be rejected. We can add a second argument with a callback function of the promises constructor, in this case called reject. This function will be called when the promise is rejected and can have any error object as the argument. This is a good time to mention that if an error occurs within the callback function of the constructor, the promise will also reject, regardless of the fact that the reject function hasn't been called. To make this more interesting, we will add some code that will make the reject function have a roughly 1 in 2 probability of being called. Now, as you can see, after a few attempts, an error is called. We can handle any errors that might be thrown by the promise by chaining a method called catch. Remember, then methods return a promise, so this is not an issue. The catch method also works much in the same way as then, but the callback function's argument is of type error.